In the previous video, we studied about velocity time graph, and also we learned that the distance traveled can be calculated from the area under the straight line. Now, this is for constant velocity. Suppose if I take the next case, again the time axis is in hour and the y-axis is in velocity, which is in kilometer per hour. Let us say I have a data with me, right? The time which is in hour and I have got velocity which is in kilometer per hour. Okay? Now 0, 0, 1, 10, 2, 20, 3, 30, 4, 40. Let us say this is the data I have got. I have to plot the graph. 0, 0 over 1, 10, 2, 20, 3, 13, 4, 40. Fine. So these are the plots I have done. Okay. So let me take the scale and let me join these points. Fine. Let me join these points. Fine. Now, this is a sloped line. Here, we are going to calculate, this is a velocity time graph. We can use this graph for two purposes. One, what I am going to do is, I am going to calculate the slope. What is slope? Y value upon x value. So let me choose 2 points. Let me take this point A and let me take this point as B. Let us drop a perpendicular to the x-axis and let us drop a perpendicular to the y-axis. Let us say this point is C, right? Now this is y value and this is x value. Now what is y value? BC. BC stands for 40. 40 minus 20, we will write here 40 minus 20 divided by. Now we will come to the x value, that is AC. C 4, A 2, so 4 minus 2, that is equal to 20 divided by 2, which is equal to 10 kilometer per hour. So the slope is giving us acceleration. What is acceleration? Acceleration is change in velocity divided by time taken. Acceleration is final velocity minus initial velocity upon time, from which we found the first equation of motion. I hope you understand now that using the slope of this, we can calculate the acceleration, which is 10 kilometer per hour square. Kilometer per hour square. Meter per second square. Now, I can use the same graph to find the distance traveled. How can that be done? Area under the straight line AB. Instead of AB, let me call it as OB. Let me take the whole triangle. For example, what I have done here is, I have taken this point A off and C off, and let me drop a perpendicular. Fine. And this is the point now C. So this first part is completed, right? We found the slope. Now second part, we are calculating the distance travel. Distance traveled is area under the straight line. Okay, that is OB. So this whole thing is being locked inside the shaded part. Okay, now what is the shape you see here? It is a right-angled triangle. Okay, for a triangle, the area is half into B into H, half into breadth into height. Okay, that is half into. What is the breadth? OC, time axis. OC, that is 4 hour, multiplied by height of the triangle BC. C is 0, B is 40, so 40 minus 0, which is 40. So let us cancel 4 and this 2 times. So 80 kilometer is the distance traveled by the body, which we can calculate from this graph. So, graphical representation is very important because it gives you a visualized picture. Fine. So, in velocity time graph, this is one type of graph and this is another type of graph. This stands for uniform velocity, where acceleration is taking place. The body is accelerating after every 1 hour. It's going on increasing its velocity. So, we can calculate from the slope, acceleration, and from the area under the straight line, we can calculate the distance. And the last one is for a non-uniform motion. Again, it will be a curved line. It will be a little bit complex. Okay. So, with this, we complete today's exercise. Thank you.